Welcome my dear students. How are you? I hope you are all well. Today we shall learn about refraction. What is refraction and what is its characteristics? We all learn today. So our today topic is refraction of light. What is refraction? When light goes from media 1 to media 2 whose optical density is different, then at the interface of two medium, the ray of light, if light incident obliquely at the interface of two media, then at the point of incidence, the light changes its path. The light, if this interface was not there here, then the light will go along this direction. But due to this interface, the incident ray will bend from its original path. This is known as refraction of light. So, when ray of light obliquely incident at the interface of two media, then at the point of incidence, the ray of light changes its path from its original direction. This is known as refraction of light. Now, if we draw a perpendicular to the surface at the point of incidence O, two angles are formed. The incident ray makes with the normal is called angle of incidence I, and the incident ray and the refracted ray makes with the normal is called angle of refraction R. So this is the picture of refraction. Now I want to explain why refraction occurs, why the ray of light is bent at the interface of two media. This is because we now learn the cause of refraction. Light goes in different speed in different medium. Here different medium means their optical density is different. The optical density is not equal to mass density. Optical density means in which a ray of light travels with lighter velocity or greater velocity. If light travels in a medium with greater velocity, it is called rarer medium, and if light travels with smaller or slower velocity, then it is called denser medium. The two densities, that is mass density and optical density, are not equal at all. दोनों एक चीज नहीं है. Mass density is mass per unit volume. Mass density is m by v. So mass density and optical density is two different things. Like mass density of water is greater than turpentine oil, but optical density of turpentine oil is greater than water. This is the basic difference of mass density and optical density. Now, when light go from one medium to another medium, its speed is different. This is medium 1, say it like air, and this is medium 2, say it like water. So, in air medium and water medium, the velocity or speed of light is different. So, the light changes its direction, original direction, and bend at the point of incidence at the surface of interface. So, light changes its direction and refraction occurs. Now, when no refraction will takes place. Now, if light incident normally then I equal to R, that is angle of incidence and angle of refraction equal to 0. Therefore, no refraction or bending of light occur. If light incident normally, then it passes straight without any deviation. So, here the angle of incidence and angle of refraction is 0. Here no refraction occurs. And number 2, when refractive index of two medium is same, are same. Suppose we take glycerin in a jar and a glass rod is immersed into the glycerin, then we cannot see the glass rod, as the refractive index of glass rod and glycerin are same. So, there is no bending of light occur and we cannot see the glass rod inside the glycerin. These two are the situation where there is no deviation of light from going from one medium to another medium of different optical density. Now, what is refractive index? Refractive index is given in terms of speed of light. It is denoted by mu is equal to c upon v. That is, c is speed of light in vacuum and speed of light in medium. This is take any medium like glass, water, any medium. So mu is written as c by v, speed of light in vacuum and speed of light in medium. We can remember the velocity of light in vacuum is 3 into 10 to the power 8 मीटर पर सेकेंड. ये जो स्पीड ऑफ लाइट है वैक्यूम में, इसका जो मान है इसको हमको याद रखना पड़ेगा. कभी कभी क्वेश्चन में ये नहीं देता है, सो वी कैन पुट इट एज 3 into 10 to the power 8 मीटर पर सेकेंड. Now, in terms of wavelength, mu equal to, we know that velocity v equal to nu into lambda. Velocity equal to, v is velocity, nu frequency, and lambda is wavelength. From this relation we write c as nu into lambda vacuum VAC and v is nu into lambda medium MED. आप लोग को दिमाग में एक बात चल रहा है कि सर ये दोनों में ही न्यू क्यों लिखे हैं, क्यों ये nu1 एंड ये nu2 नहीं हो. You should know that when light goes from one medium to another medium, only one quantity remains unchanged, that is frequency of light. So in vacuum or in medium, nu remains unchanged. So we can cancel out these two terms and we can get lambda vacuum by lambda medium. This is the definition of refractive index. If we write in letter, we can write that the refractive index is defined as the ratio of speed in vacuum of light and to its speed in that medium. It is the ratio of speed of light in vacuum to its speed of light, but to its speed in that medium. And in terms of wavelength, the refractive index is the ratio of wavelength of light in vacuum to its wavelength in that medium. This is the most important relation to make numerical solve. And this term mu here is called absolute refractive index. Absolute refractive index. Absolute refractive index. समझ में आया है? Now we go for relative refractive index. रिलेटिव मीन्स, रिलेटिव का मतलब क्या होता है? विथ रेस्पेक्ट टू अनदर मीडियम. रिलेटिव का मीन्स एक का दूसरे का मतलब से. सो a relative refractive index is written as 1 mu 2. This is refractive index of medium 2 with respect to medium 1. So, relative refractive index is the refractive index of medium 2 with respect to 1 is written as 1 mu 2. So, 1 mu 2 equal to refractive index of medium 2 with respect to medium 1. It can be written as V1 by V2, that is velocity of light in medium 1, velocity of light in medium 1 divided by velocity of light in medium 2. Velocity of light in medium 1 by velocity of light in medium 2. V1 by V2 equal to this. इस फॉर्मूले से हम समझ सकते हैं कि क्यों लाइट रे मूव करता है. सो दिस इज द रिलेटिव रिफ्रैक्टिव इंडेक्स. If light rays goes from air to water, so mu air to water is equal to, we can write V air, that is V water. Velocity of light in water, air divided by velocity of light in water equal to mu water by mu air. This mu and this mu have difference. This is mu, sorry, we can write it glass for convenience. So, this is known as glass and this is glass. This 2 mu is absolute refractive index because this is with respect to air, but this is refractive index of glass with respect to water. Refractive index of water with respect to glass. With respect to glass. So, now we can write why light rays changes its path. When light goes from rarer to denser medium, now mu equal to, if medium 1 to 2 light comes, this is medium 1 and this is medium 2, this is angle of point of incidence and this is a normal. Now we know mu 1 to 2 is equal to sin I by sin R. This is I and this angle is R. Sin I by sin R. So, in this case equal to V1 by V2. Now, if V1 greater than V2, then what happens? Sin I greater than sin R. V1 greater than V2 means V1 by V2 is greater than 1. So, sin I by sin R is greater than 1, that is sin I greater than sin R, or I greater than R. So, in this case, when light goes from rarer to denser medium. How can we know rarer? That is, velocity in medium 1 is greater. I already told that in medium in which the light goes with greater velocity is known as rarer medium. So, when light goes from rarer medium to denser medium, then the angle of incidence is greater than refraction. So, if angle of refraction is less, then it must be bent towards the normal N1, N2. This is the picture of refraction of light when goes from rarer to denser. Here angle of incidence is greater than angle of refraction. Now, take second question, from denser to rarer. From denser to rarer medium. As we know, 1 mu 2 is equal to V1 to V2, and now if V1 less than V2, and this is of course equal to sine of I by sine of, this is the second law of refraction. The sine of angle of incidence, second law of refraction is mu equal to sine I by sine R. You know, that is the sine. Sine means the trigonometric angle, sine theta cos theta. That is the sine of the angle of incidence, and the ratio of the sine of the angle of refraction must be constant and is equal to refractive index of that medium. So, if V1 is less than V2, then V1 by V2 is less than 1. Therefore, obviously sine I by sine R is less than 1. Therefore, sine I less than sine R and I is less than R. So, when light grows from denser to rarer medium, this is medium 1, this is medium 2. Here velocity is V1, here velocity is V2. Which is greater? V2 is greater. So, this is rarer. Now, this is rarer medium and this is denser medium. So, when light goes from denser to rarer medium, R is greater than. So, if this is I, then the refracted ray, this is R. Then refracted ray goes away from the normal, and here angle of refraction is greater than angle of incidence. This is the basic cause of refraction of light and basic theory of refraction of light. This is the also physical significance of mu. What mu tells? That the direction of light ray, if the refracted ray move towards the normal or move away from the normal, is say the mu. This is the physical importance of mu. Let us understand it with an example. Numerical 1. If a light if a ray of light of frequency 5 into 10 to the power 14, if a ray of light of frequency is given 5 into 10 to the power 14 Hertz is passing through a liquid of some refractive index, of some unknown refractive index, the wavelength of light, that is lambda, is measured as 450 nanometer, that is 450 into 10 to the power minus 9 meter. Then find the refractive index of that liquid. Light ray, a light ray of frequency 5 into 10 to the power 14 Hertz is passing through a liquid of unknown refractive index, and the ray of light, wavelength of light is given as 450 nanometer. We know 1 nanometer equal to 10 to the power minus 9 meter. Then what is the refractive index of mu? We can write, as we know, mu equal to C by V. Mu equal to C by V. So, from this we can determine this. So, we can calculate V. We know the velocity of light in vacuum is 3 into 10 to the power 8. Now, the velocity of light in the medium V equal to nu lambda, that is nu equal to, we can write V equal to nu lambda, nu equal to 5 into 10 to the power 14 into lambda equal to 450 into 10 to the power minus 9. We can put the value 5 into 10 to the power 14 into 450 into 10 to the power minus 9. So, 3 into 10 to the power 8 and this minus 9 if goes, then this is 10 to the power 17, 10 to the power 17, and in the denominator 10 to the power 14 is minus, that 10 to the power 17 minus 14 divided by 5 into 450. If we calculate it, we get the value of mu as 1.33, 1.33. That is, the liquid is nothing but water. As we know, the refractive index of water is 1.33. In this way, we can solve any numericals using refraction of light. So, if you like my class and understand the basic properties of refraction, please subscribe and subscribe my channel, comment in which topic you want to discuss with me. Thank you very much for watching this.